Next, we have Jonathan Jennings. He's the current project meteorologist for the West Texas Weather Mod Association, of which Sutton County is also a part of. So we work with Jonathan. He's been there since 2011, and he's also worked with the Trans-Pecos Weather Mod Association and Rolling Plains Water Improvement Program. Again, I encourage you to look at the program to read the rest of his bio or use the mobile app. So we'll get started with Jonathan. Thank you.
Can everyone hear me on this mic? I like to walk around a little bit. Hopefully I don't fall off the stage. All right. Again, I'm Jonathan Jennings. I'm the project meteorologist for the West Texas Weather Modification Association out of San Angelo. Real quick, I just want to say how humbled I am by the support I have in the crowd. A lot of my colleagues are here, as well as two of my great mentors, Scott Holland and Joe Morris. So thank you guys. It's been a great 12 years so far in Texas, and I'm looking forward to another 12. I'm going to challenge everyone real quick to forget all you've ever heard about cloud seeding. A lot has happened over the last 20 years, and we've kind of figured things out a little bit. So take all this information in with an open mind, and we'll see where we stand at the end. To get started, we're going to talk about the target areas. Where exactly do we work? I'm going to give you a quick background on what exactly weather modification is. We'll go over some of the analysis that we have conducted, and then look at some of the benefit cost analysis. And if we have a little bit of time, we'll go over a bit of a climate outlook if you guys have questions in that regard. So here's the target area map for the state of Texas. We're really close to the South Texas Weather Modifications Association program, which is run by the Evergreen program, and they have a contract with the Edwards Aquifer Authority where they cover the 4 northern counties, Uvalde, Medina, parts of Bexar, and Bandera County. And then to the north, we have the West Texas program, which is out of San Angelo, and then further to the west, the Trans-Pecos program out of Pecos or Barstow, Texas. And then to the north, we have the Rolling Plains program, which now includes Scurry County. They're a new addition to the target area for this season. And then up to the north is the Panhandle Groundwater Conservation District, which covers areas to the north and east of Amarillo. These are some of the key folks attached to the programs right now. A lot of these folks are here. Brittany's here, myself. The Rolling Plains program is Gary Walker and Lindy Patton, who some of you all might know. And then the TDLR, who licenses and regulates the weather modification activities in Texas. Their representative, Adam Foster, many of you are familiar with, is also here today. So why exactly do we modify the weather? Well, demand for water continues to increase while the supply decreases. That's not news to anybody in this room. But clouds in Texas, especially those in West Texas, are very vulnerable to smaller particulates like dust, aerosols, and these are hygroscopic particles that start to rob moisture away from the more hygroscopic particles, which allows for condensation growth to occur much more rapidly, allowing for rainfall to be more efficient. But also, it's not groundbreaking news, but Texas is very susceptible to drought. We all know that. We're in the middle of a pretty good one right now. And it's also been said ENSO, the El Nino Southern Oscillation conditions, so that's El Nino and La Nina, impacts the state of Texas more so than any other state in the lower 48. So when we have a La Nina, like we've seen over the last few years, it's going to be primarily pretty dry. And when we have an El Nino, which we're transitioning into right now, it's going to start getting pretty wet. So we're able to take advantage of more cloud resources during those El Nino years, but during those La Nina years, our effectiveness is a little bit less because we just don't have the resources available, and that's clouds. The program goals are pretty self-explanatory. We're trying to increase water supply for drinking water, irrigation, increasing levels in areas, lakes, and reservoirs. Also, aquifer recharge is a big part of that as well. But we also hope to reduce the need to irrigate and consume groundwater, but one of the biggest misconceptions in weather mod is hail. We also do hail suppression. I'll explain that in a little bit here. So the methodology, we have 2 types of cloud seeding we do in the state of Texas. The first is called glaciogenic seeding, and you can see on the aircraft wing here, these real little flares, they're little 27, 28 gram flares. They contain silver iodide, which is structurally very similar to an ice crystal. And what we're trying to do is take those really small particles that don't have enough surface area for freezing to occur and trick them into thinking they're ice. Upon contact, they create ice. So When the surface area is too small, there's no freezing occurring. They become super cold, and that super cold water interacts with the silver iodide, and all of a sudden you start to get ice in the cloud. But also, these smaller droplets don't have enough surface tension that when they collide, they don't coalesce. They just continue to bounce off one another. So we have all this moisture in our clouds, and it becomes congested, and it's just not able to precipitate. So the aircraft flies at the base of a convective thunderstorm. The pilots find inflow, and when they feel that inflow based on the vertical speed indicator of their aircraft, they fire these flares. And the material gets pulled throughout the cloud, at the base of the cloud, and into the freezing level of the cloud, and starts to interact with the supercool liquid water. Sounds crazy, but we've done flight tests, penetrating clouds. This is a huge, huge science in the atmospheric sciences, and there's been a lot of testing done that proves that this is, in fact, ongoing. Recently, since 2011, we started doing some hygroscopic seeding, and these are more calcium chloride particles. So calcium chloride is essentially salt. You only need 65% relative humidity for condensation to occur. And what we're doing here is trying to target the cloud base to the freezing level. So we're looking at the warm cloud layer. And this is where those small particles really reside. And we're able to get this calcium chloride into the cloud. Condensation occurs very quickly. And based on the burn temperature of our flares, we can control the particle size. And of course, the particle size we're looking for is anywhere from 3 to 10 microns in diameter. And that's exactly what we're able to produce based on the temperatures of the flares. The flares, in fact, are all manufactured out of San Angelo. So all these flares are built here in Texas. But hygroscopic seeding has been more on the research side of things from 2011 to about 2015. And then we started using them operationally. Our pilots describe using the hygroscopic flares like taking a knife to the bottom of the cloud and just seeing all the water rush out. So it's been very exciting seeing the growth in weather modification when it comes to hygroscopic seeding in Texas. Of course, we have to have convective storms. So this is a summertime program. Typically, we start work sometime in mid-March and continue through early October. We have to have that super cold liquid water, so we're looking for clouds that have a vertical depth beyond the freezing level. And we also need to have that inflow, and that inflow is generally started by heat. So we need to have that afternoon heat. It's very rare for us to work in the mornings because we don't have as much of that. Typically, our operations will get started somewhere between 3 and 5 o'clock in the evening, continuing all throughout. Also, we have to have VFR flight conditions, so we need to be able to choose where we go and access these clouds. If we have IFR conditions, our cloud bases are going to be pretty low. We're going to have probably cooler temperatures, not as much heat. So VFR is the way we go, and it allows us the freedom to move throughout the target areas without having to file a flight plan. So here's a really good picture of one of our aircraft. This is burning a hygroscopic flare. And you can see the rain shaft, that light color throughout here. And then this is a scud cloud, which is typically a good indication of very strong inflow. So when you find that inflow, the pilot lights the flare, and you can see the trail getting pulled right up into the cloud. So I talked about hail suppression. And if you think about a 5-gallon bucket of water, allow that 5-gallon bucket to grow into 5 ice crystals. Those are going to be very large ice crystals. It's going to be hail embryos. What we're trying to do is take that same 5-gallon bucket of water and create 5,000 ice crystals. So instead of getting the large damaging hail, we get more either just rainfall or we get small pea-sized hail, which has actually been proven. There's a lot of programs up north along North Dakota, Alberta, Canada, even down into Argentina, where hail suppression has funded millions and millions of dollars. So hail suppression is certainly one. It's not our primary goal, but it's an offset of what we do with our rain enhancement operations. So exactly how does this work from day to day? Well, the meteorologists, myself, we issue a morning forecast to local landowners, groundwater district managers, pilots, and whoever else is interested in the program. We look at the large-scale operations. We look at the GFS and European models and try to figure out what kind of conditions we have in the synoptic scale. And we start to funnel that down into the mesoscale. So we'll be looking at sounding data, which is our weather balloon data. We're trying to identify exactly where the freezing level is for that day. We're trying to look for the convective available potential energy and other parameters that help the meteorologist make decision-making during the operations. We then look at the high-resolution model, so the HER model or the NAM model. These are much smaller grid models, these actually allow us to pinpoint location and timing of precipitation, and that's critical for our operations because timing is very important. We need to get to these clouds early before we start to get growth of hill embryos and get a lot of material into the clouds before that starts to happen. So I'm able to give the pilots an idea. All right, we're going to operate around 3 o'clock. Let's be in at the office at 2. Let's pre-flight the airplanes, be ready to roll by 3. And it's been great. But really, in the last few years, this GO-16 satellite imagery updates just as rapidly as radar. So radar updates every 4 minutes, and it used to be we would get a satellite image every 15 minutes, and it would already be 15 minutes old. But now we're getting the images like this on satellite just as much and just as new as radar data. So we're able to identify areas where it's whiter, and that shows a thickness of the cloud. We look at the shadows to try to figure out the vertical depth, and then we overlay that with the SBC mesoanalysis, and we figure out, is there surface convergence there? Do we have good upper level dynamics? Is it unstable? Is the cap broke? So we're really able to pinpoint timing. Most times we're able to get airborne before we even have a signature on radar. And that's where we go next is radar, and that's kind of what drives the whole operation. We use a program called Titan. So it's thunderstorm identification, tracking, analysis, and nowcasting, more acronyms. But it's an operations and evaluation tool. And we're able to look at real-time cloud parameters and track these individual clouds and get to certain parameters. So we're looking at precipitation max, we're looking at precipitation flux, amongst many other parameters. And in real time, in good cases, we're able to see these clouds respond in dramatic ways that we usually don't see in nature. But most of the times, it's hard to really see that. So it's more of a post-operation evaluation tool. We do have our flight tracks on there, so you can see exactly where the aircraft is. That's great for safety, because sometimes we could get into a bit of hard rain or hail. And it also allows me, the meteorologist, to get really precise with targeting. So we like to see these notches. Those notches is where wind is kind of pushing into the cloud, and that's where we usually see the good inflow. But also, we're able to take a cross-section analysis of the cloud and see exactly where these cores of higher DBZs are. So we're looking at these higher reflectivities. That's the radar sending out a signal. It's hitting something, and we're getting a return back. So the brighter the signal, the more return we're getting. So typically, something like 60 to 65 DBZ is going to be a lot of rain. When you get into the 70s, that's when you start dealing with some hail. But we look at that core and we say, all right, that core is above the freezing level, so we know glaciogenic seeding is a tool for us today. Or sometimes that core does not extend beyond the freezing level, so we know only to use hygroscopic flares. All this data then gets sent off for an evaluation at the end of the season, and that's conducted by Dr. Archie Ruiz-Colombi out of Texas Tech University. He takes all this data, compiles it together, finds control clouds within the same air mass, because we want to make sure we're dealing with similar clouds, and we create a database for the last 19 years. This is our 20th year of using the WSR-88D radars for the evaluations, and we have over 5,000 clouds. So this evaluation has been ongoing since '02. And really, when Archie showed up, things changed for the weather modification programs in Texas. We really started to get an idea of dosaging. That was a very important aspect of what we were doing. Before that, we were grossly underdosaging clouds and having little to no impact. But now, before we were firing 4 to 5 flares per cloud, we're doing 3 to 4 flares per inflow, upwards to 20, sometimes 40, 50 flares in a single cloud. But over that 5,300 clouds that we've seeded, we are showing an increase of about 13%, and that's for the statewide. You can see how things differ for the West Texas area, which is the longest running program in the state of Texas. We're seeing about a 2-inch increase since 2004, or about a water production of about 1.16 million acre feet. The Trans-Pecos program, their opportunities aren't as abundant as some of the other programs, but we're still making an impact of about a 1/2 inch. And they've committed to the program a lot more over the last 5 or 6 years. So we're expecting to see a lot better data coming out of the Trans-Pecos program. This is a chart that pretty much should sell everybody on exactly what we're doing here. So this is precipitation flux over time. So the units here are meters cubed per second. So we're looking at a volume of precipitation over a period of time. So this is essentially telling us how hard is it raining. And the red line is our control clouds. So these are the unseeded clouds, 5,300 unseeded clouds versus the 5,300 seeded clouds. And you can see that our clouds are outperforming by a significant margin the precipitation flux of the unseeded clouds. So we are making it rain harder, precipitation enhancement. But also note that the unseeded clouds are starting to dissipate around the 110-minute mark, where the seeded clouds, they don't quite dissipate until the 130-minute mark. So they're lasting about, on average, 20 minutes longer. Well, why exactly is that? Well, if you take a super cold liquid water and you phase change it to a solid, it releases heat into the cloud. So just like a hot air balloon, the more heat you put in it, the more it'll expand, the more it'll grow, and the longer it'll last. And we're doing the same exact thing with the clouds that we're seeding. So all this heat's going in the cloud, is expanding, and it's lasting about 20 minutes longer on average. Of course, we wanted to look at what we're seeing, the ground truth. So we looked at the rain gauge data and tried to figure out if that matches what we're seeing on the radar. And we did the precipitation study for the San Angelo area, and you can see these are 5-year moving averages. In 2001, that's when Archie showed up, we really started to figure things out. We were increasing our dosaging by 50, 60, 70%, and our targeting was getting better, our timing was getting better, and our forecasting was getting better. So we were doing really well until 2011. 2011 just skewed all the data. We only had 9 inches of rain in San Angelo that year. So there weren't a lot of opportunities, but since then we've gotten back on track and things are looking good. But if you look at the data as a whole, the West Texas area since 2004 is showing 104.5% of normal precipitation. When you compare it to all the rain gauges outside the target area, so this is west, north, and east, we're seeing about a 97% of normal, or a change of about 7%. But these clouds are lasting longer, and they're moving downwind, going into areas to the east and northeast of the target area, and they're contaminating these rain gauges. So when you look at an area that doesn't get any contamination, the west areas of the target area, we're seeing about a 16% increase, which is right there on par with the evaluation from Dr. Ruiz. So we're pretty confident in the evaluation that Dr. Ruiz has given us. And this is just showing the same inside the target area blue and then to the west. So you can see how those gaps are a bit enhanced. So let's talk a little bit about recharge. Dr. Green and Bertetti did a really good study showing that 16.5 inches over a long period of time is kind of that target number year to year for seeing recharge. But I really like this map showing areas to the east of this line. Typically, they're going to see recharge in areas that support it. But within that area, right where the West Texas program is, maybe you see recharge, maybe you don't. It could be dependent upon that 2 inches of precipitation that's enhanced on year to year. So these lines can move back and forth on any given year. And weather modification could be the difference between seeing recharge over a 10-year period versus not seeing recharge. Areas to the west, unfortunately, folks out in Reeves County to the west, recharge isn't going to be happening quite as much. But we did do the study showing the recharge enhancement based on the weather modification programs using all the work that Dr. Green and Bertetti did. And we were able to show during a 10-year period, we could produce about 1 million acre-feet of additional recharge into the Edwards Trinity Aquifer. So we really want to try to model this data and see if this data is correct. But we've definitely taken a conservative approach when it comes to this. So we are pretty confident in these numbers. Year to year, you can see how that changes. Again, some years we get that 16.5-inch threshold. Other years, like 2011, we don't. But this is really, this is a long-term look at things. So just average this out over the decade, and that's where we're getting our numbers from. In 2014, we reached out to Dr. Jason Johnson. He's an agricultural economist, and asked him to do a benefit cost analysis of the weather mod programs in Texas. And, his background is ag, so he only looked at these 3 areas of agricultural production. So increasing dryland crop revenue, cost savings to irrigated acreage, and increasing grazing land revenue. And he showed for the programs that participate, we're seeing about a 1 to 16 direct impact for the target areas, or statewide impact 1 to 34. So For every dollar the programs are putting in, we're seeing a return of $16 to $34. And this is only looking at these 3 areas of agricultural production. For the West Texas area, we're seeing on a year-to-year basis, again, this is 04 or 2014, so this is already becoming pretty outdated. We're seeing about a $6 million return year to year on a budget that runs between $300,000 and $350,000 a year. So the impacts are pretty great when it just comes to agricultural production. But of course, we haven't looked at the recharge enhancement. We haven't even looked at enhancing spring or river flow. All these other parameters that are in place. Fire suppression is one that nobody really thinks about. Improved habitat, conservation for wildlife. So there's all these little side benefits in weather mods. So that $6 million impact pays for the program itself, obviously. So we would like to study some of these areas. So again, if you're a groundwater modeler or you have some expertise in any of these, reach out to us and we'll be glad to work with you. So what's in the future of WeatherMod? Well, in 2017, the USDA reached out to our group. They had a technology which utilized a electrostatic system, which we put onto an agricultural aircraft or an air tractor. And we were seeding clouds with water, electrostatically charged water. And these droplets coming out are 200 micrometers in diameter. They're big droplets. They get pulled up into the cloud. And we've had some pretty eye-popping results with this project. Now, it still has a lot of refinement to do. We still have a lot of data to collect, but we like where it's going. And in fact, a lot of folks are trying this throughout the world. The United Arab Emirates, which is one of the leaders in weather modification in the world, they've reached out interested in this technology, and we're hoping to get a grant from them soon. So the USDA, that work will continue over time. We also have big projects going on all across the Mountain West for snowpack augmentation. The Snowy project in Wyoming was huge for the future of weather modification. And we really like what they're doing in the snowpack seeding augmentation. So the future of weather modification is bright. And I think, as the stress or the stresses of water continues, we're going to start hearing more and more. And I think we already have over the last couple of years of weather modification in Texas, in the U.S. I'm sorry. So don't really need to go over the conclusions, except I really want to point out, this is a long-term water management strategy. This is not something that's going to break a drought overnight. We're not going to fill rivers and reservoirs overnight. This is a long-term project. In fact, during the drought of 2011, Will Wilde, the former director of water utilities in San Angelo, stated, without the WeatherMod program, we would have run out of water that year. So this is certainly something to look at for a long-term project. I would not recommend joining a program thinking you're going to fill up a river or a reservoir overnight and then give up. This is something that if you are interested in, you need to really commit to. Just wanted to leave off with a pretty cool picture. Our pilots, they're a little crazy sometimes, and they get into the thick of things. They see a lot of lightning. We have a lot of really good video. Unfortunately, I didn't want to bring any video here and cause any hiccups, but the pilots get into some good stuff, and they have a lot of fun doing it. It's one of the more unique meteorology jobs, and certainly one of the more unique piloting jobs. And we have a really, really good group of pilots, good group of folks involved. So if we have any time, I'll take some questions. If you're interested about a little bit of a climate outlook, I do have some insights into next year. Yes, sir.
So I have a question. Is this on? Is it on? Okay. I like the sound of enhancing rainfall recharge. I'm just wondering, it's 2 parts to it. Do y'all record rainfall intensity and duration and total on the ground?
We rely on the great folks of the water districts to report back to us. So we get a lot of rain gauge data coming back from all the folks throughout. And that data gets sent off to Dr. Ruiz for the evaluation. So that's a big part of his evaluation, is looking at rainfall intensity.
Measure rainfall intensity, not just storm totals?
Yeah, we look at where the rain gauges are available that shows that rain gauge intensity. We definitely incorporate that. But in West Texas, those are few and far between, unfortunately.
So that's one really important characteristic for rainfall recharge because of rainfall characteristics and thresholds. The second part of it is really directed to Ron, if he's in here. I saw that, because you referenced his project a couple of times about, I guess, 16 plus inches being kind of the sweet spot. And my question is about the intensity and duration there as well. Do you
I don't know if
about that?
Dr. Green's in here or not, but that's certainly incorporated into it, I believe.
Yeah, that's a long-term average, and the 16 and a half is just a rough estimate of what that break is. It really has to do with the intensity and the pre-existing moisture content. Those things are not factored in. We're just looking at, that's over many years, and that's where it breaks, but it's going to vary from year to year.
Okay, and was that just, do you remember which counties you looked at?
That was about an 8 or 10 county area, mostly around Val Verde, Crockett County, in that area. So it's right in that transition area between the semi-arid and subhuman.
Okay, thank you.
But those very similar data were observed in South Africa and India. So it's not just a local thing. It's all, if it's similar, temperatures, similar rain and the like.
Thank you.
Yeah.
Microphone back there, please. Oh, here, there it is.
Thank you. Any correlation with your view of the sky as you have with chemtrails, and what can you tell us about that?
Well, I can tell you right off the bat, it's not us. We're flying anywhere between 5,000 feet to 12,000 feet. So, we're far below a lot of the ideas of chemtrails are 30, 35, 40,000 feet. We would blow our yearly budget in one flight. But as far, we're working when it's clouds all over the place. So we don't get a really good viewpoint of that. Our pilots don't report anything. I'm stuck in an office. So no correlation as far as I know.
Okay, one more real quickly, 'cause we're
Have y'all done any analysis on if you're getting water out of your clouds in this county, what effect it's having on the counties?
Yeah.
Say it's going to the southeast.
Sure,
Have y'all
sure.
looking at any effect on anything like that?
Yeah, robbing Peter to pay Paul, right? I should have mentioned this, but, a cloud isn't a closed box. If we're pulling moisture out of a cloud to precipitate it over Sutton County, it's going to replace that moisture with the surrounding environmental moisture. We don't have a moisture problem in Texas. In fact, we have over 300 inches of potential precipitation that goes through the state of Texas on any given year. We're just trying to squeeze as much out as we can. So like I mentioned, we're releasing that heat into the cloud. So we're actually seeing a downwind impact where we're helping everybody. So we're paying Robert, we're paying Paul. But as far as robbing Peter to pay Paul, that's one of the misconceptions of WeatherMod. I'd be glad to talk more with you if you'd like after. Thank you.